Hello everyone and welcome back to the channel. This is day 23 of CCNA course and we are talking about OSPF verification and troubleshooting. I'm just going to show you some commands that are very important and I'm going to show you how you can read the results of these commands because in the beginning it might be a little bit daunting seeing just the results, but now you can see that everything is going to be super simple. Which parts of the results are super important for you to take a look at and what part of the result might be of less importance. That's going to be are speaking in here. So the first thing that we have to do is show IP route. I'm going to go to my lab. This is my lab that we have done some stuff on this before. And I'm just going to go to router 1, let's say. And what I'm going to do is to check for some of the log messages. You can see that some of the log messages say that right now we are done with the OSPF loaded. The first thing that is very important is going to be show IP route. Now this part, of course, in a small network is going to be super easy to read. But when the network grows, this is going to be very huge. So the output is going to be very huge. So you can see that there are different types of routes that are in my table. Most likely, the routes that are going to be with L, which is the local subnet, C, which is the connected interface. These are not going to be of interest for you. Maybe there are some, let's say, routes that are marked with a static or S, which means that we have a statically configured that. You can just say show IP route, or you can say show IP route, let's say OSPF, or show IP route RIP. If I just go for here, you can see that after show IP route, I can press a question mark. And you can see that there are different types of routes that we can take a look at that. We can even check the distinct routes separate from other routes and see the output about this route in more detail. Alright, now you can see that for protocols, I can check BGP routes, EIGRP, ISIS, and let's say OSPF, OSPF v3, which we are going to talk about later maybe, and RIP, and these are the dynamic routing protocols that you can check. But right now, like I said, if I just hit enter, a bunch of routes are going to appear here. And based on the size of your network, of course, these routes are going to be huge. On the internet, we have something like, I don't know, 1 million routes or something like that. Based on the time that we talk, this number can be different. So how can you just read through this? The most important part is going to be this first letter. O stands for OSPF, which means that this route is generated here by OSPF calculation. You can see that in here I have the prefix itself. There is the actual prefix, but the network is upper than this. You can see that 2000/32 is a network, and it says it is subnetted, and this is just one subnet. You can see that this is /32, which means that this is a host route. A host route is one and a single IP address, only one. So this is going to be this one, 2222. And you can see after that it says that the administrative distance, or AD, is 110. Even if you do not take a look at this O in the beginning, you would guess that this is an OSPF route because OSPF has administrative distance of 110. Of course, you cannot really be sure about that. You need to make sure that this is advertised by OSPF because you can change the administrative distance of even a static route. Or some other router protocols, you can just change the administrative distance. And after that, there is the real cost to get to that specific subnet. Right now, you can see that the cost is 11. The cost is based on bandwidth. So whatever the bandwidth is, there is going to be a reference number that we call it reference bandwidth. That is going to be divided by the bandwidth of the link, and whatever number that we have, that's going to be the cost of the link in here. Now, based on that, you can understand that the lower the cost, the better the path towards the destination. And after that, you can see that this has been here for 2 minutes 21 seconds, and it is accessible via Ethernet 01. Like I said, if you see an IP address instead of an interface, this means that you have to take a look at that IP address again inside this routing table. That is called recursive routing. So we have this in here. Going back to my slides here, you can see that I have another type of route which is called OIA, or inter-area route. Okay, let me just take a look at this. If I just go back to my topology in here, you can see that every device that I have here is inside the same network. Now, I can just say, okay, let's say router 6 is in another network, and I'm just going to configure another area for this. So what I'm going to do is to just drag it out. Let me just say this is going to be a little bit smaller. Okay, so I'm just going to have another area for this specific router here. And then when we have multiple areas, what we need to have is kind of a router which is in between these areas. So this is going to be my router 5. So what we call this is ABR actually. Now we need to change the configuration. This was area backbone, and what I'm going to do is to change this to 1. Area 1, let's say. And this is going to be this. Now the configuration should change. As you can see that A00 from router 5 is in area 1. So the configuration should change. So what I'm going to do is to go to router 5 and I'm going to say show run interface E00. This is the configuration that we already have. IP OSPF 1 area 0. I need to change this. So I'm just going to say interface E00. I'm going to say IP OSPF 1 area is going to be 1. Now after this you can see that some things is going to happen. For example, the adjacency is going to fade. Why? Because my router 6 has not changed the configuration. It was previously area 0. So this is telling the other one that I am in area 0. This says I am in area 1. So that's going to be not match. And it's going to fade. So I need to change it. So I go to R6. So on R6, I say show on interface E00. And you can see that this is in area 0. Also, interface look like 0 is the same. So I'm going to change this. So go to configuration, interface E00, IP OSPF 1, area is going to be 1. So this means that now we are a match. Now you can see that this is loading. And also interface look like 0. This is going to be the same thing. Okay, now that we have this, I'm just going to show you something. If I go to router 6 and say show IP route, you can see that most of the routes now are inter-area. This means that I have received these routes from some other areas other than the one that I am inside. I can do the same thing on R1. If I just go to here and check IP route, now you can see that 6666 is from another area, which means that this is inter-area. This is not inside my area, this is inter-area. So that is what we have as inter-area. Also, we have external routes. Now, external routes could be of 4 different types. 2 of them are listed here. We can have E1 or E2, and also we can have N1 and N2 based on the type of area that we have. Later, we are going to check that. But right now, we already have something like that. So if I just check here, you can see there is an external route that I have received from router 3. And router 3 has received it from somewhere else. But anyway, what I mean is this is an external route which is injected into my network. Okay, going to the next slide, show IP OSPF. That is very great command to check a lot of different things. So on R1, what I'm going to do is to say show IP OSPF and hit enter. You can see that a bunch of information is going to appear in here. Some of the most important ones are this. Routing process is OSPF, the process number is 1, my ID or router ID is 1000. You can see that the OSPF process has started something like 11 seconds ago or something like that. And the time has elapsed something like, no, the last time is this. And something like 10 minutes, 22 seconds ago, this has started. And you can see that it says that there is just type of service 0, which is not so important. It says it supports opaque LSAs. These are LSA type 8, 9, and 10. And there are some other important information. For example, what type of area we are supporting and what type of area we are in. Right now, it says that this router is not originated router LSA, which means that we are in a point-to-point network, and some stuff, other stuff which might not be so important for now, but these are the important information. The area is backbone. The number of interfaces in this area are 3, and area has no authentication configured. And some more stuff that you can just read through that. These are going to show you some part of the configuration. SPF statistics and timers are in here, which means that when was the last calculation? This was obtained like 11 seconds ago. And this is very much useful for checking the overall health of the OSPF process. Now the next one is going to be the OSPF interfaces. We already know that there are three interfaces in OSPF process. Now if I say show IP OSPF interfaces brief, or you can just say interface. I'm not going to say brief because now I'm going to see some more information about each one of the interfaces. You can see that there's a bunch of information here that you can just take a look at. For example, the first one is going to be Ethernet loopback 0. Next one, Ethernet 01. Next one is going to be Ethernet 00. And these are the three interfaces that we have in OSPF process. Now information for loopback, of course, because loopback is a virtual interface, is not so much. And loopback, of course, does not participate in any kind of adjacency. But you can see that there are some stuff in here that is worth mentioning. For example, the IP address, the area, and how is this attached to us, and what is the process ID that this interface has become part of that. What is the router ID? What is the network type? You can see that the network type for loopback interfaces by default is loopback. You can change it. But what is the cost to reach to this loopback interface? The other one, Ethernet 01. This is up. LAN protocol is up. The IP address is this one. Area is this one. And you can see that the cost to reach it is something like 10 because that's an interface with a length of 10 megabit per second. And the reference bandwidth, like I said, which is a reference number to calculate the cost, is by default 100 megabit per second. So 100 divided by 10 is going to give us a 10, which means the cost of this interface is 10. And some more information here, for example, what are the hello timers and dead timers configured on this interface, and how many retransmits have been supported, which means that right now we have not changed the timers. That is the default timer which is configured for this specific interface. So you can see that there are different things, and network type is very important. Here you can see that this has a state of VDR, which means that I have not changed the network type in here. The network type should be by default broadcast, and of course I can just take a look at that. If I check here, it says that the network type is broadcast. So there are different ways to understand what is the network type, what is the information in here. Okay, so let's go for the next command, which is show IP OSPF neighbor. But before that, let me just take a look at this interface. I showed you the show IP OSPF interface, but I'm just going to show you the IP OSPF brief command in here, which is going to show you some important information in short. For example, what are the interfaces? What is the process ID of the OSPF, because you can have multiple processes? What is the area which is contained in this interface? What is the IP address and the mask? What is the cost? And what is the type of the network? And of course, the state of the network right now. So these are very important. But show IP OSPF neighbor is going to show us how many neighbors we have. But right now, before going to that, show IP OSPF interface brief shows some information about the neighbor. You can see that it says right now for loopback interface, I have no neighbor, no adjacency. Ethernet 01 says there is one neighbor and one full adjacency in here. So these are the numbers that are important. But I'm just going to show IP OSPF's neighbor and hit enter. It tells me that these are the neighbors with this router IDs that they have. The priority, I have not changed them. The state is full, and I am designated router. And also the interface, which is reachable, this neighbor is reachable through, and stuff like that. You can just check it, check that in here. The other one is show IP OSPF database. Now this one is going to be a big one. So if I just check this, show IP OSPF database, and of course the variations of this command, you can see that the amount of information is huge. Right now, of course, this is not so much because my network is not so big, but when your network becomes big, the amount of information is going to be super huge, and you cannot really go through the whole database just by eye. So you need to go for some refining the commands using piping and then checking with specific thing. But different types of LSAs are here. Right now, I have LSA type 1, which is router, LSA type 2, which is network, and also LSA type 3, which is summary network. And these are the types that we have in here. Other types, of course, there is a type 5, which is the external network, and we can take a look at this and see what routes are advertised, who is the advertising router, which is very important. For example, I have received 10.122 from router 2. I have received, let's say, 6666 from router 5. That is because router 5 is my ABR for now. And show IP protocol. This is going to be one of the first commands actually you check. I always start with this to see what kind of protocols are configured on my network. You can see that right now there is the first one, which is application, which is, this means nothing specific, support of different routing protocols. The next one is OSPF with different things. For example, do I have any ACLs configured? What is the router ID? What is the number of areas that I have right now? What is the maximum patch supported? This one is important for ECMP. Later we are going to see that. We have these interfaces which participate in OSPF processes, and also these are the gateways, which means that I have access to external networks using these different paths. So you can see that there are different information which is important for us in this here. So there are real world examples that you can just use for troubleshooting. For example, if you see that two routers from different vendors want to form adjacency, you have to go through the configuration. OSPF is a standard. This means that normally you should not really have any problem with that. But there might be some configurations that can be different on different platforms. For example, the hello timers are important, the MTU configuration is important, and authentication is important. And these are the things that you need to go through to see what the problem is. But normally, the configuration is going to be the most important part of the problems that you see here. For example, you see hello messages, but you can never reach the full adjacency. This means that there might be an MTU problem, or there might be some misconfiguration again here. Timers or cost calculation might differ between different vendors' platforms, and all you need to do is to just make sure that timers are correct, cost has been configured correctly, the reference bandwidth is almost the same. Of course, reference bandwidth is not going to do anything in global configuration. That's going to be locally significant for each one of the routers, but again, you need to be careful, because then checking the cost, of course, is going to be a little bit confusing for you. What you need to do is to just go through your labbing. Again, I'm working on PNetLab and EvenG are almost the same. You can go with Packet Tracer, which I have showed you. CML is another option, and GNS3, of course. Or real gear, of course, would be a benefit, but you are not going to see any difference between this and the real gear. You need to configure a single area, or what I did right now, you can configure interfaces on multiple areas. Set loopbacks as router ID, which means that you're not going to do anything specific. If you have multiple loopback interfaces, the higher IP address is going to be selected. If you want to have a specific IP address for router ID, or router IDs and IP address which is not configured on your router, then what you need to do is to set router ID manually. And then go through the verification commands that we just checked and check to see what is there. The more you see this, the more you're going to be comfortable with the results. So OSPF is the go-to IGP in many real networks. Like I said, that's because OSPF is standard. And you can understand neighborship, designated router, backup designated router, router IDs, different types of LSAs. You can configure single area or multiple area, but for CCNA, you are not supposed to configure multiple area, although I just did it for you. And this is going to be a powerful practice story. And verification commands are going to be your best friends, of course. Be very careful about verification commands, learn them, and try to use them instead of checking the configuration to find the problem. Okay, this has been our day 23. Thank you for watching. As usual, like, share, and subscribe to the channel. Hit that bell button so that you're going to receive the notification, and hit that super thanks button. This is going to be a huge support for us. See you in later videos.